So let's see this. Oh, foo. I don't know. So yeah, but it doesn't matter because you're going to get high resolution in the Zoom recording, at least of the screen shares. So let's see. Yeah, this is going to be kind of ugly too. I was having problems with my internet, so I reset my computer like on Sunday or something, and so I haven't got anything installed. I had to reinstall. I haven't got a development environment or anything like that. Okay, so this is going to be a little bit faster. So what we're going to do is say, okay, I'm going to choose my separator is going to be Hansen-Lunenburg. And so what I'm going to do is for every way to color Hans and for every way to color Lunenburg, well, except that I don't want Lunenburg to be the same color as Hans, right? So I'm going to choose, I'm going to look at this separator, and then I'm going to count the ways to color the mainland. So if Lunenburg is equal to Hans, I can just stop there because it's not a valid 3-coloring because they're adjacent. And otherwise, what I'm going to do is say, okay, then I'm going to add to a counter the number of ways to color the North mainland and the number of ways to color the South mainland. So notice, I know like the people who teach programming would hate me because I'm using global variables because I'm lazy. This is like a 200 line, I don't know how many lines of line program it is, but so global variables like aren't going to kill me here. Okay, so how do we compute the North mainland? So well, we go through all of the things. Now here I'm just doing brute force. I'm just going to go through in alphabetical order even, doesn't really, I mean, it's so small it doesn't matter in this case. And I'm going to say, okay, Antigonish, for all the colors, all the ways to color Antigonish. Antigonish doesn't touch Lunenburg or Hans, so I don't have to check anything. Colchester, all the ways to color Colchester. Colchester, I have to check that it doesn't touch Hans. Cumberland, make sure that it's not the same color as Colchester. Go through and say, okay, so I go through all of these and make sure they're not conflicting with the separator and they're not conflicting with each other, and if they don't, then I add 1 and then I return. So this is my function to count the North mainland, the number of ways the 3 color the North mainland, given a coloring of Hansen-Lunenburg. And then I do the same thing for the South mainland. And then I do the same thing for Cape Breton Island, okay, which is easy. So I'm just going to go to participants for a second and ask, how do I make this bigger? Stop share, okay. Okay, I want people to think out, like, could you, now, I posted both of these little code snippets on Brightspace, but if they weren't there, could you write this yourself? So I'm going to ask you to put up your hands. Could you, if I asked you to, now, yes, you can count the colorings of Nova Scotia, so 3 people could do it, with a little bit of thought. Okay, so a separator, there are algorithms to find small separators in planar graphs. I'm not going to teach them to you, because actually I don't know. I mean, I heard it described that a separator, you'd sort of take the planar graph and you draw a line down it, and then you like try to pull stuff to either side until like the stuff is about half and half. And I love the way that the guy described it. He said this intuition is not entirely wrong. It's probably not entirely right. But yeah, okay, there are algorithms to find, polynomial time algorithms to find small separators in planar graphs. But for this, you would just eyeball it, right? you just look at it and say, okay, I want a small set of counties such that when I remove them, then it sort of breaks Nova Scotia up into little pieces. So you don't have to remove anything to break up Cape Breton Island from the mainland. And then if you look at the mainland, you think, okay, how would I do a separator? If you drew it as a graph, you'd be like, well, here I can take these two out, and then it's sort of half and half. And then if you want to do it recursively, you'd be looking at the North Mainland, and you'd say, oh, I could do, what did I say? You could do like Pictou and, you could do, yeah, if you remove Pictou and Halifax, then you separate Cumberland and Colchester from Antigonish and Guysborough. Okay, so that's, if you look at the code, where is this code on Brightspace? Under assignment 1. If you look at the code, so let's just share the whole screen. If you look at this code, so this is the faster way. I'm assigning, these are global variables, I'm assigning colors to Hansen-Lunenburg, which are my separator, and then I'm calling count the number of colorings of the North Mainland, and when I go here, when I assign a color to Colchester, I have to make sure it's not the same color as Hants. So notice that, so the North Mainland, I'm having to check against the separator. But I'm never having to check against the coloring of the South Mainland. I can count the North Mainland and the South Mainland independently because they don't touch, because if they did, it wouldn't have been a separator. Okay, so chat. Okay, so the this is I want you to I want to traumatize you. So like later in life, if anyone ever mentions divide and conquer, you think, oh, the colorings of Nova Scotia. I don't want you to think like, oh, divide and conquer, it's merge sort, it's only good for easy stuff. No, I want you to, like, I want this to be burned into your memory. Okay, so what we've got, I'm going to stop share. So people could figure out, like, okay, you can see that if you want to count the colorings of Nova Scotia, you can count the colorings of Cape Breton Island and count the colorings of the mainland. And then if you want to count the colorings of the mainland and you want to do it quickly, then you could actually say, well, I'm going to take out Hansen-Lunenburg, and for every way to color those, I'm sort of running out of time. I'm going to consider the ways to do the north and the south, and they don't have to. Ooh, somebody raised their hand. We can stop sharing, and then I can actually let somebody allowed to talk. You can unmute yourself if you want. Okay, or not, or type. How? No, only the person who I unmuted. Okay, but maybe there's no microphone. Okay. Okay. I will. So you can type in the chat. Maybe. Okay, but so I will remute you. Let's see. So remember that if I do this with the naive algorithm, it's not slow, but it's slow-ish. And now let's, now the thing is, remember the first time this runs, it takes a while. But if we do it fast, notice that I just type it and it's there. Are you seeing my screen? Oh wait, I have to share the screen. Sorry. Okay, I have to share the screen. Okay. So people can see my screen, I hope. Okay, so if we do this with the naive method, like it's not slow, but it takes like a second maybe. If we do it with the fast method, it's just there. No, okay, that's the naive method. The fast method is like you just hit enter and it's done. Okay? So that's like woohoo, like we spent half an hour, something like that. I don't want to remember how much time I spent last night, like writing this faster implementation to save all of like a second. But, so now we get to your homework. We have 15 minutes left. So how have I... So is this still... How is the battery dying already? I charged the battery yesterday, so it only lasts one lecture? Okay, so chat. They do make batteries like they used. Well, they don't make them like they used to. They're supposed to make them better. I'm going to complain to Jeff. What's his name? Jeff Houghton, the battery professor. Okay, so people can see this. So let's talk about your homework. So I'm not really using the board at the moment. So device separator. Oh, the recurrence. Right. I'm going to stop sharing. So if you've seen the homework, this is asking you to count not the 3 colorings, because actually it looks like that map is not 3 colorable. It's not obvious, but I changed the code to see if it could count the 3 colorings. It came back and said there are 0 3 colorings. So in some maps, it's like, remember I drew, if you have, the example people usually use is if you're 4-coloring the United States, to show that it's not 3 colorable, there are actually, where did the blue marker go? There are some states down by like California and Nevada where you have like 5 or 6 states, and you can check and see, okay, these are not 3 colorable. But I couldn't see an easy subgraph of your assignment, of the map on your assignment, that is not 3 colorable, but apparently it isn't. At least the code says it isn't. So maybe the code is wrong, I just wrote it last night. But the question is, how many 4 colorings are there? So there are 42 regions. So if you brute force it, it's going to be, and you do something really dumb, like you just run through all of the regions and try all of the possibilities, and then at the end you check and see if they're compatible. You'll be trying 4 to the 42, which is, so 4 to the 5 is about 10 to the 3. So that's about it's like 10 to the 25 possibilities. So even with modern computers, it's not going to work by the time the homework is due. I don't think. It's not going to be like 3 to the 18, and it just finishes in a fraction of a second. I hope, because I want to actually make you do this with divide and conquer. Time complexity auxiliary.